Hello students, today we're going to discuss about ICSE Class 10 Chapter 2 Chemical Bonding. Before we discuss about chemical bonding, you have to know what is actually chemical bond. Everything in this world wants stability. So is the case with atoms. For atom, stability means having the electron arrangement of an inert gas. That is group 18 elements electronic configuration. You take group 18 elements helium, neon, argon, krypton, xenon. Helium has 2 electrons in the outermost shell. Neon, argon, krypton, xenon, radon. These elements has 8 electrons in the outermost shell. So helium has 2 electrons, that is duplet electronic configurations, while all other inert gases, that is neon, argon, krypton, xenon and radon, have 8 electrons in their outermost shell. It is found that the elements with their complete outermost shell, which has 8 electrons in the outermost shell, that is octet electronic configurations, do not react or least reactive. Therefore, conclude that the atoms having 8 electrons in their outermost shells are very stable and unreactive. To attain stability, atoms tend to combine. Atoms combine, they form molecule actually. So atoms tend to combine chemically by redistributing of electrons in the outermost shell or valence electrons, so that each is left with a stable electronic configuration. So atoms, they combine chemically by redistributing the electrons which is present in the valence shell, and they achieve stable electronic configuration. So overall, a chemical bond may be defined as the force of attractions between any two atoms in a molecule to maintain a stability. There are 3 methods in which atoms can achieve a stable electronic configuration. The first one is the transfer of one or more electrons from one atom to other atom. And if it achieves the stable electronic configurations by transferring one or more electrons from one atom to other, and it's called as electrovalent bond or ionic bond. Second one, sharing of 1, 2 or 3 pairs of electrons between two atoms to form covalent bond or molecule bond. If they achieve stable electronic configurations by sharing 1, 2 or 3 pairs of electrons, the bond between these atoms are called covalent bond or molecule bond. Third one, when the shared electron pairs are contributed by only one of the combining atoms, the bond formed is known as coordinate bond or dative bond. We're going to discuss about all these. There is 3 types of bonds. So types of chemicals bonds: finally ionic bond, covalent bond, coordinate bond. We're going to discuss one by one. First, ionic bonds. So in ionic bonds, there will be a transfer of electrons, one or more electrons from one atom to other atom in order to achieve stable electronic configurations, in order to get complete electronic configuration. Ionic bonding. An ionic bond is formed by one atom transferring electrons to other atoms. So if it is transfer electrons, of course it become cation. So when an atom achieve electrons and it become anion, so it will get oppositely charged particles. So an ionic bond is formed by one atom transferring electrons to other atom to form oppositely charged particles called ions, which attracts each other. This electrostatic force of attraction is called as ionic bonding and is most likely formed when metals combines with non-metals. And you people have a clear idea about the metallic and non-metallic characteristics of the elements. and the metals and non-metals. A metallic element whose one atom readily loses electrons to form a positively charged ion is an electropositive element. Example, you take sodium. Sodium has more tendency to lose electron and it forms positively charged ion. Sodium has more tendency to lose electrons. So sodium has more metallic character and behaves as a metal. A non-metallic element whose atom readily accepts electrons to form a negatively charged ion. Example, you take chlorine. It has more tendency to gain electrons so that it has more non-metallic character and behaves as a metal, and is also known as electronegative elements. And this is about valence electrons in each group and the valency. The first group has 1 valence electrons, second group has 2. This is about the 13 group. It has 3 electrons in the outermost shell. And this is about 14. It has 4 electrons in the outermost shell. And this is about the 15, which has 5 electrons in the outermost shell. 16 has 6 electrons in the outermost shell. And 17 group has 7 electrons in the outermost shell. This is about the valency. If it has 1 electron in the outermost shell, the valency is 1. If it has 2 electrons, the valency will be 2. If it has 3 electrons, the valency will be 3. If it's 4, the valency is 4. But if you take a nitrogen and oxygen halogen family, nitrogen family has 5 electrons in the outermost shell. As it is in need of 3 electrons, it gains 3 electrons, so that valency will be 3. Oxygen, valency of oxygen family is 2. Halogen family, it's 1. Atoms of metallic elements that have 1, 2 or 3 valence electrons can lose electrons to atoms of non-metallic elements which have 7, 6 or 5 electrons respectively in their outermost shell, and thereby forming electrovalent compound. So metals transfer electrons to non-metals and they form electrovalent compound. This is formation of sodium chloride. Sodium has 2, 8, 1 electronic configuration. After it lose 1 electrons, it form sodium cation. Electronic configuration of sodium cation is 2, 8. Chlorine, electronic configuration of chlorine is 2, 8, 7. After it receive electron, electronic configurations will be 2, 8, 8, and this is called as chloride anion. So transfer of 1 electrons from sodium to chlorine form oppositely charged particles, that is sodium cation and sodium chloride anion. The force of attractions between this oppositely charged particles Na plus and Cl minus is called electrovalent bond. Condition for the formation of electrovalent or ionic bond. First one, low ionization potential. What is actually ionization potential? The energy required to remove the electron from the outermost shell. If one of the atom has low ionization potential, then it will be very easy to form electrovalent bond. If the low ionization potential lose electron easily, cation is formed easily. So if it has low ionization potential, electron will be released very easily, cation will be formed very easily. Next, high electron affinity. If any one of the atom has high electron affinity towards electrons, that is tendency to gain electrons, is higher. If it has higher electron affinity, gain electron easily and form anion easily. Next, large electronegativity. If the difference in the electronegativity of two elements is higher, then transfer of electrons will be easier. So electronegativity, this is also about electron affinity, the tendency to gain electrons. If the one of the atoms if the one of the atom has more electronegativity, one of the atom has lesser electronegativity, then the tendency to form the electrovalent will be greater. Okay, so if the difference in the electronegativity of two elements is higher, then transfer of electrons will be easier. Then you will get electrovalent compound very easily. The metals of group 1, 2 and 13 have tendency to lose their valence electrons. So they combine with non-metals of group 15, 16 and 17 which have tendency to gain electrons and form ionic compounds. So group 1 elements most electropositive has more tendency to lose electrons and they form positively charged ion very easily, so that they are called electropositive elements. Group 1 elements are most electropositive. Group 17 elements has more tendency to gain electrons and they form electronegative ion more easily. So they are called they are called electronegative elements. Group 17 elements are most electronegative. And cesium fluoride is the most ionic compound. Cesium is has more metallic character. Fluorine has more non-metallic character. Cesium and fluoride, there is a fluorine which forms cesium fluoride, is most ionic compound. Examples of electrovalent compounds: NaCl, magnesium chloride, calcium oxide, potassium bromide and calcium chloride. See, sodium, magnesium, calcium, potassium are metals. Chlorine, oxygen, bromine are non-metals. So electrovalent bond formed between. Comparison of properties of sodium atom and sodium ion. Sodium atom has 11 protons and 11 electrons, but sodium ion has 11 protons, 10 electrons. Properties of sodium atom and sodium cation. Color. Color of sodium atom is silvery white. Sodium cation is colorless. Toxicity. Sodium atom is poisonous. Sodium cation is non-poisonous. Chemical reaction. Sodium atom is very active. Why? Because it has incomplete outer shell. In order to get complete electronic configurations, it participate in chemical reaction. Sodium cation is inactive because it has complete outermost shell. Valence shell. Sodium atom has incomplete outer shell. Sodium cation has complete outer shell. Electronic state. Atom is always neutral. Sodium cation carries 1 unit of positive charge, so it's positively charged. Existence. Sodium atoms exist in a combined state. Sodium cations exist independently. Comparison of properties of chlorine atom and chloride ion. Property. Chlorine atom, chloride ion. Color of chlorine atom yellowish green. Color of chloride ion is colorless. Toxicity. Chlorine atom is poisonous. Chloride ion is non-poisonous. Odor. It's a suffocating. Chlorine anion is odorless. Chemical action. Chlorine atom is very active. Chlorine anion is inactive. And this is because of the complete outermost shell. Valence shell. Chlorine atom has incomplete outermost shell. Anion. Chlorine anion has complete outermost shell. Electronic state. Always atom is neutral. Anion carries negative charge. Existence. Chlorine atoms non-independent. Chlorine anion is independent. Sodium atom combines with one chlorine atom. So one electron transfer from sodium to chlorine forms oppositely charged particle. The force of attraction between this charged oppositely charged particles create ionic bond. Sodium, chlorine. Sodium has 11 proton and 11 electrons, but sodium cation has 11 protons, 10 electrons. Chlorine atom has 17 protons and 17 electrons, but chloride ion has 17 protons, 18 electrons. So this is how you have to represent the outermost electrons. This is called electron dot structure. With help of this dot, you have to mention the outermost electrons. Sodium combined with the chlorine. Sodium transfer an electrons to chlorine forms sodium chloride. Sodium loses an electron, gets oxidized. Chlorine gains an electron, gets reduced. Sodium gets oxidized by chlorine. So chlorine is an oxidizing agent. Chlorine gets reduced by sodium. So sodium is a reducing agent. As one species is ready to transfer electron, another species is ready to accept the electron. So sodium gets oxidized by chlorine. So chlorine is an oxidizing agent. Chlorine gets reduced by sodium. So sodium is a reducing agent. Next, valence electron in each group. First group has 1 electron. Second group has 2 electrons in the outermost shell. 13th group elements has 3 electrons in the valence shell. 14th group elements has 4 electrons. 15th group elements has 5 electrons in the outermost shell. 16th group elements has 6 electrons in the outermost shell. This is 17th group. 17th group elements has 7 electrons in the outermost shell. This is 18th group, inert gas group elements. Except helium, other elements has 8 electrons in the outermost shell. This is about the valency. So which has 1, 2, 3 electrons in the outermost shell as 1, 2, 3 valency respectively. The valency of carbon family is 4, nitrogen family is 3, oxygen family is 2, halogen family is 1, 0 group is 0. Magnesium one magnesium atom combines with one chlorine atom to form magnesium chloride. Magnesium has 2 electrons in the outermost shell. So it has 2 electrons to lose. Chlorine, which is in need of 1 electron. Here, 1 magnesium combines with 2 chlorine atom. So magnesium 2 plus Cl minus, that is chloride ion, 2 chloride ion. So magnesium combines with 2 chloride ion and transfer 1 electrons to this chlorine and 1 to this chlorine, 2 chlorine atoms. So it forms electrovalent bond between magnesium and 2 chlorine, so that we are getting magnesium chloride. This is the electron dot structure of magnesium. Chlorine, this is actually chloride ion, this is also chloride ion, this is magnesium. Complete electronic configurations. See, this is an electron dot structure. By using this electron dot structure, the dots you have to represent the outermost electrons. Magnesium has 2 outermost electrons, chlorine has 7 outermost electrons. 1 calcium atom combines with 1 oxygen atom to form calcium oxide. Calcium 2 plus O2 minus. So calcium has 2 electrons in the outermost shell. So it's donate 2 electrons. Oxygen, 1 oxygen atom is in need of 2 electrons. So it forms oxide ions O2 minus after it received 2 electrons from calcium. So this is the diagram. This is a complete electronic configuration of calcium and oxygen. So calcium has 2 electrons in the outermost shell. Oxygen has 6 electrons. It is in need of 2 electrons. 2 electrons transfer from calcium to oxygen. So it's create 2 oppositely charged particles Ca2 plus and O2 minus. The force of attractions between the Ca2 plus and O2 minus gives you electrovalent bond. This is the atomic orbit structure. structure of calcium and oxygen, and calcium ion and oxide ion. So oxygen has 2, 6 electronic configuration, but O2 minus has 2, 8 electronic configurations. Calcium 2, 8, 2 is the actual electronic configurations. After it loses 2 electrons, it becomes Ca2 plus 2, 8, 8 electronic configuration. Thank you, students. Please subscribe for more videos.